Here recently. We continue to look
right.
for upper altitudes as Falcon 9 flies
Okay.
through periods of
The New York ingest server just took a dump, guys. I'm
Finally,
reconnected
on
through
the
Miami.
Ranger
We should be
course,
good.
We have cleared the danger areas, the hazard, the caution
All right.
areas.
Picking up the
Everybody's
count.
out of there except the 4-person crew up in the Dragon capsule, very top of the rocket. You can see in the picture. So coming up, T-minus 28
Hopefully that's the
minutes,
extent of the
30
problems
seconds,
today.
everything continuing to look good on Falcon
Yeah,
9
Bears, you're right.
for the Axiom-1 mission.
Let's take a moment now to get acquainted with the vehicles that you see
AOS
there on your
1549.
screen. That's a live view of
Copy
Falcon
all.
9 with Dragon, our spacecraft on top.
Okay.
Falcon 9 rocket
Condensation's
is a rocket,
happening right there. They started fueling.
Falcon 9 rocket with the Dragon spacecraft on top together stands
Morning,
about
Eugene.
250.
Canadian, what can you do? I could sit here and whine about it, or I could keep teaching you about the rocket and get those viewers back, which we will. You know, kind of annoying, but gotta be ready for a curveball, dude. So, check it out. They started loading liquid oxygen into the vehicle here. You can tell from the condensation that's forming on the outside. That condensation happens because Falcon 9 gets cold. Liquid oxygen is a cryogenic propellant. That's a really cool scientific way of saying it's really freaking cold. Oxygen usually exists as a gas down here. To get it to a liquid, to get it into liquid state, you need to cool it. So, I mean, in chat, you need to cool it too. No, I'm just kidding. So what happens is they get it to the liquid state, obviously, and then they pump it. They start pumping it into the rocket, and that gets the outside of the rocket cold. It gets the outside of the rocket so cold that it reacts with the humidity in the atmosphere and freezes it. So you get condensation on the outside of the vehicle. There's a shot from the drone ship. Short fall of gravitas here. He's looking pretty calm. This is not bad. A little bit of white caps going on there, but seems okay. They're going to try to land the first stage out here, particularly, hopefully, in the center of the bullseye. That would be good.
Great, the blue skies. I don't think it could be.
Nah, not really, John.
No, it's like a desktop right there, I think.
Our drone ships are essentially autonomous, powered spaceports that allow our rocket to land over the ocean. For reference, our drone ships are equivalent to the size
It's
of a
not
football
tourists.
field.
They're
So,
going to do science,
while it may
Astro.
look kind of small on
Commercial
your screen,
astronauts,
they're
dude.
actually pretty ginormous in real life.
It's got to be to hold a rocket, right? As mentioned previously, Falcon 9 is a two-stage rocket. It's 2 rockets in one. Above the first stage is the second stage. Now, the second stage
Airplane?
has a single Merlin vacuum, or MVAC, engine, which ignites after the first stage separates.
What do you mean try? Yeah, good call. All right. Loading the helium in. Believe it or not, the second stage and the first stage on Falcon 9 do use helium as an ullage propellant. Now, I was talking about the nitrogen attitude control systems on Falcon 9. They have basically compressed nitrogen that they shoot around to get the thing to steer the vehicle in space, right? When the motor's not on, right? But inside of the fuel tanks, they also have helium, in like I said, being used as an ullage propellant. What is an ullage propellant? What does that mean? Ullage? Oh, okay. The ullage propellants are basically gases, or the ullage gases are gases that are inside of the fuel tanks, inside of another fuel tank. There's a fuel tank in the fuel tank. Actually, it's a gas tank inside of a fuel tank, but whatever. It's fine. You know, who would be non-technical with rocket science, right? You don't have to. You could be plain. No, that doesn't work that way. So they have compressed helium gas inside of tanks or bottles that are inside of the main fuel tanks. Now, why do you need those? Well, tank ullage is something that you have to balance with a rocket. Because if you think about it, the rocket's at flight pressure, or it's at pressure. The tanks are pressurized, so they have a lot of fuel in there, and that fuel is at a high pressure. But as the rocket drains the fuel, the pressure would go down. You don't want the rocket tank to explode, or not explode. You don't want it to implode on the way up. That would be not ideal. So what they do is to take into account the pressure dropping inside of the tanks from the fuel draining out. They pump helium gas into it, and that helium gas takes the space of the liquid fuel to make sure that the pressure in the tanks doesn't change anywhere on the way up. You want to make sure that the pressure stays the exact same in the liquid fuel and oxidizer tanks on the first and second stage all the way up. So if they're draining fuel, they're pumping helium in. And once again, why do they use helium? Well, helium is inert, first of all. It won't combine with the liquid oxygen, for instance, and explode. Because if you were using like hydrogen or something, that would combine with the oxygen and you'd Hindenburg yourself. You don't want to do that. That would be bad. I don't think I need to say why. Helium is non-reactive, and it's also really light. Low mass. Very low mass. Nietzsche's graphic artist is amazing. Yeah, I know, right?
Into orbit. As Stage 2 heads towards its targeted drop-off orbit, Stage 1 will execute 2 burns in order to make its way back to Earth.
Foliage
The first stage is the
What?
entry burn, where 3 of the Merlin 1D engines will reignite and then shut down.
At what temperature does oxygen become a liquid? 293 Fahrenheit. You can use exclamation point convert to convert units back and forth if you need to.
That was ignited right after stage separation.
Please say why.
Once
Explosions.
this happens, we'll wait for confirmation of good orbital insertion.
It's
About
minus
90 seconds
293
after
Fahrenheit,
Dragon
guys.
gets into orbit, Falcon 9 will
180
land
C.
back on Earth. The
Thank you,
landing
Floater.
burn, which is a single engine burn, will bring the vehicle's speed down rapidly in order to land on the drone ship at about 9.5 minutes into the mission.
It's true, Captain.
And while Falcon 9's first stage is landing, Dragon is preparing to separate...
It's loaded in gaseous form, Hinks, because you want to be able to compress it. You can compress gas. You can't compress liquids. So they keep the helium as gas. Yeah. So somebody asked what the mission is. This is the Axiom-1 mission, AX-1. This is a crewed launch to the ISS, but it's the first commercial astronaut launched to the ISS. Now, these guys that are on board, they aren't tourists. They're going to go up there and they're going to conduct commercial science operations on the space station for about a week, and then they're going to come back down. This is history right here. No commercial entity has ever moved commercial astronauts to the space station before. A commercial entity has moved commercial astronauts to low Earth orbit before, but they've never gone to the space station. So this is a big deal. How long? And I know the next question. How long is it going to take? 24 hours to get to the space station. They make sure that the spacecraft is in good health before they send it to the ISS. There's no undo button in space. You've got to be sure.
Hours ago, NASA Flight Director Diane Daly gave a go on behalf of the combined ISS team to the SpaceX mission director.
Our Starship
just
is
saying
part of
that
Artemis,
ISS,
Lux.
or the space station,
Don't
was
get
go
confused.
for launch. Now, to get there, we've got a list of flight rules, basically just guidelines for all of the major systems we have to make sure are functioning onboard station before we can give a go to launch.
There's nothing
another
in the
crew
trunk,
up there.
Sile.
So we're looking
Not
at
today.
everything from those core critical command and control computers, verifying we have a good communication path through our tracking and data relay satellites, ensuring that the atmosphere, all of the life support systems on board are functioning, even the mechanical systems like the docking port where this mission is headed. So we're expecting today's flight to be about a 20.5-hour journey from launch to docking.
Well,
with the
Hanks, cryogenic helium just could be cold gas. I mean, if I'm remembering right, getting helium to be a liquid is very difficult. So it might be, but I would need somebody to double check. You'd have to double check me on that because now I'm not sure.
3 NASA astronauts and 1 ESA European astronaut, and they're joined by 3 cosmonauts that just arrived on station about 2 weeks ago. Now, so it's going to take them about 20.5 hours to get there.
You guys
That
love the
docking
convert
right
command,
now
huh?
is targeted for 11:45
Thank Drummer for that one.
GMT on Saturday. That's
Stage 2,
6:45
RP loaded
a.m.
complete.
here in
Yeah,
Houston.
and that's what I was
4:45 for
thinking.
the teams over in Hawthorne. And so once they get there, they'll be able to get out of their suits on board the Dragon spacecraft, while the team on board station moves into what's known as the hatch
Okay,
operations.
look at the background.
Station Commander Tom Marchand is going to be pressurizing.
So if you not to kind of put lower Dan's volume here, but if you look at the back, see that cloud of smoke coming off of that? What they're doing is they're cooling down the fuel lines in the transporter erector for the second stage. They start filling up the first stage a little bit earlier. Why? Well, why do they do that? Because it's bigger. SpaceX wants to make sure that the first stage and the second stage finish fueling at the exact same time. So they start fueling the first stage a little bit earlier, and then the second stage a little bit later, so they both top up at the exact same time, so you can maximize performance. All right. So what they're doing there is this white structure that's next to Falcon 9. That's called a transporter erector. The transporter erector has the fuel lines for the second stage, which is this part right here. That second stage, once again, you can't fuel it from anywhere else. You got to fuel it from there. It needs cryogenic oxygen, so it needs liquid oxygen. And, well, RP1, same as the first stage, so it's kerosene, basically. And they got to make sure that those fuel lines are cooled down. Why? Why they got to make sure the fuel lines are cooled down? What does that have to do with it? Well, once again, cold liquid oxygen. That pipe, that's the fuel line that goes up the transporter erector, is a little bit warm. Spoiler alert, it's a little warm in Florida. And now we're talking about differential temperature here. You know, the liquid oxygen is minus 180 C, and that pipe is 21 C. That's a big difference. That's a 200-degree difference in centigrade right there. 293 F to 70 Fahrenheit for everybody else. So what they do is they pump in some helium and they pump the liquid oxygen up, but they don't pump it into the vehicle, because what it's doing is it's exchanging that heat. You got to cool the pipe down, because if you don't cool it down, your liquid oxygen is going to hit that pipe and the liquid oxygen will heat up. And if it heats up, just like if you put water on the stove and you heat it up, it'll turn to gas. Can't have that. It's a liquid fuel rocket engine in the second stage, not a gas fueled rocket engine. So what they're doing is they open up a vent line to atmosphere and they start pumping helium and liquid oxygen up that line. Oh, it's time to wake up. They start pumping helium and oxygen up that line. Now, why the helium in there too? Well, you don't want to create anti-geysering. I actually learned about this the other day. You put helium in there to kind of make sure that you don't get pockets of air trapped inside of there. They do it to basically bleed the system and get it down to temperature. It's called thermal conditioning. Yeah, wake up. I usually wake up right around now to start the stream at noontime. Why is there an Axiom control center? Because they're the customer for the mission and you want a control center for your mission? No? Can we see this launch on the East Coast? Depends on where you are, Panic. Worst alarm clock sound. Have you watched a new KSP video yet? Nope. No, I haven't, Gunny. I've been a little preoccupied. I love Kerbal Space Program, guys. Don't get me wrong. It's my favorite game. But I like Human Space Program better. Yeah.
There we have begun LOX load.
I thought that SpaceX controlled the mission.
On second stage. So that is currently underway for first and second stage, as well as loading of RP1, which is...
Swishio, they do. SpaceX is controlling the Dragon capsule. But the Axiom mission is also separate from that too, because Axiom is their own company, man. You would want to make sure Axiom in the future is going to operate their own space station, so they're going to need their own mission controls, so you might as well get used to doing it sooner rather than later.
Launch.
Yeah, so I'm looking at my dashboard here. It looks like fuel load on second stage is now complete. So we're
should be able to see
that
it,
LOX
Maka.
load, as we just heard. LOX load and fuel load continues on first stage. Axiom crew continuing to wait, following along with everything happening there.
So what Axiom Space plans to do in the future is that this is the first mission to get to train some commercial astronauts on how to do station operations. That's why they're going to the ISS. Later down the road, so 2024, I think, Axiom will attach their own module to the ISS. And then they're going to build their own space station while attached to the ISS off of that core module. And then when the ISS goes away in 2030, Axiom will detach that and have their own space station on orbit, their own commercial space station. The idea is that NASA's kind of handing over the reins of low Earth orbit to a commercial sector, to a commercial economy. So NASA can focus on going to the moon or going to Mars. They don't need to operate the ISS. It alleviates their budget from doing that. So the idea is to slowly hand it over, and this is the first mission to kind of take the first steps in that direction, which is really, really cool, really interesting stuff.
Getting themselves ready and planning their research. NASA, of course, we can't do this without NASA's leadership and support.
Yeah, that's
and
why this
to
mission
each
is
of
so
you
important.
In the Axiom Space family, we couldn't have done it without you. We're looking forward to a bright future together.
T-minus 14 minutes, 7 seconds, and continuing to count down. Everything is still looking good for launch of Falcon 9 and Dragon. That'll occur 17 minutes and 12 seconds after the hour. As a recap.
What might Axiom use to launch their module? I think it's Falcon, Sile. Yep. Who will run the ISS when Axiom breaks away?
20 minutes. We've still got fuel going onto the first stage. Looks like we're about 90% or so full right now.
No, Ice
Fuel
Mage.
loading will finish up at T-minus 6 minutes, and we'll hear that call out in the count.
Sir Isaac Newton. Nice, Kralani.
Meanwhile, densified liquid oxygen is continuing to load onto both the first and second stages.
Well, when the
First stage.
yes, yeah, that was a legit question. It was a legit question because you weren't listening. When the ISS is disposed of, Axiom will separate their space station. What do you think disposed of means? They're going to deorbit it. Yeah, 2030. I mean, hopefully, personally, I hope that NASA goes over to, Elon and say, hey, can you use that Starship thing to bring the space station back down? That would be kind of nice. I kind of hope that happens, but right now the current plan is to dispose of the ISS, meaning Viking funeral, baby.
Lose the ability to put liquid oxygen onto the stages, into the tank.
It's Dragon
in the
Endeavor,
quantities we
Sebi.
want. So it stays nice and cold, it doesn't bleed off, and that gives us the performance we need on Falcon 9. Continuing
Yeah,
on
exactly,
Falcon 9,
Floofin.
check
Good
out
reference.
the thrust vector
Good reference.
controllers, what we call TVC
You may have dated
wiggles.
yourself, though.
You may hear that term. They're coming up. We're also going to be doing throttle valve checkouts on the Merlin engines. That helps control the power of the engines as we go through flight. For example, you hear a throttle down or throttle up as we prepare for the period
I'm not
of
sure,
maximum
Bauxy.
dynamic pressure.
Where's the space station going to
As we
land?
come up on the 12-minute
Ocean.
mark, the range continues to be go.
Correct,
Roadblocks
90.
are up. All the hazard areas are clear. Airspace, sea space is good. The weather is go. Beautiful shots you can
That's
see
right,
here. Blue
Justice.
skies.
Viking
I'm
funeral.
looking forward to some great views from the cameras as we head into space. And then finally on the Dragon side, the Dragon mission director and team, they're
Thank you,
reporting
T-Man.
no issues.
Third flight, Balk.
We've done the communication checkouts with the crew. You can see the crew axis arm has retracted
Rain?
into the launch position. You can see Dragon now with the strung back the transport erector and the umbilicals going to Dragon alongside of it. We've also armed the launch escape system, and obviously the crew is strapped in the Dragon capsule and they're ready to go. Final instructions to the crew will come in about a minute and a half.
There were talks about
10.
selling
We'll
it
listen
after
to that.
NASA's done with it,
The crew
Moose.
displays will be configured for launch,
Kicks.
and that setup will give the crew insight into how the
Hey.
launch is proceeding.
Just want your first
and it
badge back?
provides
Right on.
constant updates on vehicle health. The T-minus 5 minutes will be in the terminal count for Dragon. Dragon will
They
transition
repainted
to
Hinks.
internal power, going to its onboard batteries and off of the external ground power.
Flagging.
We're going to hear continued callouts on the countdown net as we go from T-minus 10 to 0, and then as we fly after T0 and liftoff,
Well, it's
we'll hear
people like
callouts
space,
as we head
KSP.
into space. And that'll be letting the crew know as they reach each of the milestones.
I haven't seen it, Rain. I've been busy with
Our
Human
next big
Space
event
Program.
coming up at T-minus 10 minutes is we're going to do launch commit criteria, and final instructions will be going to the crew. One other thing that you will hear is during ascent you may hear 1 Alpha, 1 Bravo, 2 Alpha.
Abort contingencies.
These are launch escape states. As the Falcon 9 flies, if a launch escape was required, the crew on board knows where they are
It's
passing
just a flap,
various
Sile.
points in the countdown. And
It's
that would tell
covering the
Dragon
RCS.
what sequence of events to execute to come off of the Falcon 9.
No,
and
it's
bring
not
the crew
new,
back
Fron. It's
safely
been around
down
for a
under
little
the
while,
parachute
since
in the ocean.
1961.
Right now, T-minus 10 minutes. Let's listen in to the countdown now.
Dragon,
Noth-
SpaceX, confirmed crew displays are configured for launch.
T-minus 10 minutes. Here we go. Guys, these are FOD covers here.
SpaceX Endeavor, we confirm they're configured.
These are FOD covers right here. Foreign object debris. That's covering the on-orbit thrusters, or what's called the reaction control system. They're covering up the RCS. Now, how do they get them off? Well, they'll pop off when the pressure outside goes down. So when the vehicle's going up, the flap is over the RCS thruster, and it's going to create a vacuum. And the pressure inside of the rocket engine from the ambient temperature will actually push that flap out, and they'll come off. Either that, or they'll come off when the RCS outgasses. when they turn on the RCS, it'll pop the flap off. They're just there to make sure like a bird doesn't go and make a nest inside of one of the rocket thrusters. I mean, on top of that being very bad for the bird, it also could break a thruster, and you don't want to do that. Yeah, so they put covers on them. It's literally just paper. It's something very, very inexpensive. It's like paper or whatever. And on the way up, if the ambient pressure is going to go down, those papers they'll just fly off. The vacuum will pull them off.
Not expecting Ithaca to make you rich. Ithaca gave you this marvelous journey. בהצלחה X1, בהצלחה רקיע.
Thank you, Eitan. I'm going to continue far less elegantly or eloquently, but as we sit here on the precipice of this new era in human spaceflight,
there's nothing venting out of Dragon Swishio.
Professionals at SpaceX, NASA, and Axiom.
That guy is talking.
We want to thank all the teams at SpaceX, Falcon 9, Dragon, the launch team, of course, closeout team, all of the folks in mission control, and of course our training teams. With NASA, boy, it's been tough. The first time was always hard, and there's no playbook. It's all open field running, but with ISS program, commercial LEO development and flight operations, we've learned a lot, and we'll continue to do so.
It happened with a bat on the space shuttle one time, Ice Mage, yes.
People at Axiom for putting this mission together with the amount of miracles that they perform.
Haven't shown it, Shiniken. Or Shikinen.
All of you, make no mistake, are the men and the women in the arena. Your faces are marred, if metaphorically, by the dust, sweat, and blood, and you strive valiantly. You will have no place with the cold and timid souls who know neither victory nor defeat. The crew of the great ship Endeavour is ready to sail her proudly, Arthur.
They're all Axiom employees, Demo, from what I understand.
Some heartfelt words there.
Stage 1 engine chill has started.
560
so there was the
WRs,
call
Moose.
that we have begun to chill the engines on the first stage. So what we're doing right now is flowing a little bit of the super chilled liquid oxygen through the turbo pumps on those
3 hours went by
engines.
quick,
There's
fellas,
9
didn't
of
they?
them at the base of the first stage.
We're at T-minus 6
and
minutes
that's
all of a
essentially
sudden.
bringing them down to the temperature of that super chilled liquid oxygen to prevent any thermal shock to the hardware. Just before that,
I'm not rewinding right now,
words
Switch
from Commander MLA and Mission Specialist Eitan Stiba. Really love hearing that commentary.
Commercial astronauts doing commercial science on the ISS, Reindeer. This is the first time I've ever done it. It's first commercial mission to the ISS, guys. Big deal.
At this point in time, fuel is fully loaded on both the first and second stage. LOX loading continues on both stages.
Coming up on 5.5 minutes.
Nice, Craig.
Kate's let us know that we've got the fuel load complete. Next is coming up. We're T-minus
not a
5
demo
minutes.
mission,
Dragon
John.
will be transitioning configuration for terminal count and going on its internal battery power. Everything continues to look good as we're counting down.
A little bit preoccupied right now, guys. To be fair, and you're never going to hear me say this ever. I don't care about Kerbal right now. I care about human space program. This I love Kerbal, love it with all my heart. This is my priority right now. Caraxis arm is in the retracted position.
Falcon 9 tanks are pressing for strongback retracts.
They'll be up there for about 10 days, Capcom. Kerbal's lovely, but I like human space program better.
Heard the call out. We're pressurizing the tanks for strongback retract. We'll hear a sequence momentarily. Strongback is retracting. Actually, that's the start of about a 1 minute sequence. In about T-minus 4 minutes, the clamp arms that you can see there will open, and then
Strongback is retracting.
And then we will see the retract from there. So we've heard the call out. That's the start of the sequence. Doesn't mean that the clamp arms are late opening. Will take us a few more seconds.
Okay. Tanks
As you
have to
can
be at
hear,
flight pressure for the
excitement
claws to
and the crowd
retract.
is really growing here at SpaceX headquarters at Hawthorne, California.
There they go. Tanks are at flight pressure.
There you can see the clamp arms have begun to open.
COVID,
And next
self-taught.
we should see the strong
Yep.
back begin to retract.
I'm not an engineer by trade, dude. Everything I know about this is all self-taught. I got a lot of people
This
fooled.
is what we basically use to transport the fully integrated vehicle to and from the hangar, from
Look
the
at
hangar to the launch pad.
Starship pad in the
You can see
background,
that
guys.
The strong back retraction has begun.
I'm a Frengineer.
Everything continue to look nominal as we're now under 3.5 minutes until launch.
Okay, strong back
P1
retract.
Fuel is fully loaded on
T-minus
first and
3
second
minutes.
Stage.
10 seconds.
Should be wrapping up.
Just a
launch
very big
load
Finkel
on,
fan.
the first stage.
This is my
momentarily,
Graceland, sir.
And continuing to fill
Mutter
on
from
second
Collier
stage.
County. Huh.
Stage 1, LOX load is complete.
That's in the middle of nowhere. Okay, stage 1 LOX load is complete.
We're under 3 minutes until liftoff of the Axiom-1 mission.
Everything is nominal, yep.
Dragon is in terminal count and is on internal power.
Okay, they cut the
Already
rocket
very
off
hard.
from the
Dragon's
grid.
on internal power.
Here we go. The
As I
batteries
was
on
saying,
board are
we're
powering the
getting
vehicle.
close. The crowds are growing. The excitement is palpable.
It's an umbilical
You can see there
retract
on the
line.
left-hand side of
John.
your screen, mission control
Axiom
here in
1,
Hawthorne, California,
we-
just behind where John and I are. And
Axiom
on the
1.
right-hand side, that looks like Axiom mission
That
control.
looks like Axiom mission control in Houston,
Axiom 1 is the
Texas.
first commercial
Everybody's waving and saying, hey.
Axiom 1 is the first commercial space flight to the ISS with commercial astronauts doing commercial science on the space station. This is a big deal, guys. This is some pretty big history right here.
The first stage is now fully loaded with all of its propellant.
Okay. 2 minutes.
LOX load on second stage continues. As we've mentioned before,
Stage 2, LOX load is complete.
No problem, Spark.
all right, so there's that call. At this point in time, Falcon 9 is
Dragon is in auto idle.
Okay.
Dragon is fully loaded with all of its propellants, nearly 1 million
Remember those fuel
pounds
lines I told you about?
of that propellant.
Now they're evacing the propellants out of that fuel line because you don't want fuel in the launch pad.
Started.
Right
Expect
now,
venting.
the gas closeouts. We finished pressurizing the storage tanks on board the Falcon
They're
9. We
depressurizing
threw
the
heads
fuel
up,
lines,
made some
Crayaload, that are on the
venting
transporter
noises.
erector.
We're also going to vent down the liquid oxygen line that carried the
Listen.
LOX up to the second stage. Generates a typical large white cloud of condensation around the strong back.
All right, guys.
Big event coming up now. T-minus 1 minute. All the flight computers take over. Let's listen in to the last minute of terminal count.
T-minus 60 seconds.
FTS is armed. Falcon 9 is in startup and now controlling.
Automatic flight termination system
Dragon is
is
in
in armed.
countdown.
Is armed. Excuse me. 45.
Dragon, SpaceX, go for launch.
Launch director reports. Go for launch.
SpaceX Endeavor, we acknowledge, go for launch.
Commander Michael Lopez Alegre
T-minus 30 seconds.
confirming that they are good for launch. The crew on board. 25. $15.
T-minus 15 seconds.
Stand by for sound suppressors to turn on.
10, 9,
Sound suppressor
8,
system is primed.
7, 6, 5, 4,
Engine
3,
ignition.
2, 1, 0. Ignition. Stop. Go Falcon.
We're flying.
Dragon.
Let's go.
Speed Axiom 1.
First commercial mission to the ISS. We're in mode 1 alpha, indicating the abort contingency.
A new chapter begins. Godspeed AX1.
Everything looked good.
Stage 1 propulsion is nominal.
That looked okay. Engine guy says all nominal chamber pressures on the 9 Merlin 1D engines in the first
38
stage.
seconds into this historic mission, flying crew on board Dragon and Falcon 9.
Range telemetry nominal.
Okay, the roll program is
Stage 1 throttle down.
Good to go. Stage 1 is throttling
down
back.
in the preparation for max dynamic pressure.
Max Q, or maximum dynamic pressure, is a stage during the ascent where basically the vehicle can't move the air out of the way fast enough. The air,
9 is supersonic.
the air starts to compress up against the front of the vehicle and can basically cause torsional and compression loads on the rocket. You don't want to accordion the vehicle, so they throttle down the first stage.
Stage 1 throttle up.
They throttle down the first stage to take that into account, and then they throttle back up.
Copy, 1 Bravo.
Okay, 1 Bravo
Calling out
indicates.
1 Bravo should a escape situation arise.
Yep, it's an abort
it tells the
contingency.
Dragon flight computer what profile to fly using the Super Draco engines.
Yep.
But everything is looking good on Falcon 9.
4 souls aboard. It's pretty cool, huh?
We're getting nominal callouts from all the engineers and a great view from the ground camera and the onboard cameras.
Evac chill underway.
Okay, we start to thermal conditioning. They start thermally conditioning the second stage engine here. That basically
Beginning
means
to chill in the second stage turbo pump in preparation for its ignition coming up in just over half a minute from now.
the plain Jane way of saying that is that they're priming the second stage engine. They got to get it
on
cold.
About 3.5 G's acceleration for the crew.
Okay.
We'll begin
Yeah, look at
throttling
that.
down the Merlin engines to hold that level of acceleration.
For the nerds, slightly lofted trajectory to minimize G load on the crew. You notice that the plume's going that way and Falcon 9's pointed that way.
Coming up, we're going to get main engine cutoff
Stage
of the
1
main
throttle
engines.
Okay, stage 1 is throttling down in
And stage
preparation for main
separation
engine
and
cutoff.
ignition of the second stage engine. You've heard the throttle down call out. We're holding 3.5 G's for the crew.
Yep, see? Stand by for engine cutoff. Should see a big cloud of gas puff out the back. There we go. There's the puff.
And Miko.
Stand by for stage separation.
Stage separation.
Looks good. Upper stage ignition. Looks good. You should see a stiffener ring pop off right there. Perfect. That was good. That was good. Look, you can see all the cape. Look at
Successful
that.
stage separation ignition of the second
That's pretty
stage
neat.
engine on
Look
the
at that.
left.
You can see all of
Titanium
Florida almost.
Grid fins beginning to slowly deploy. Great views from the first stage camera. The first stage now begins a slow flip
Hey,
maneuver.
WD.
You can see the white nitrogen gas plumes as
Yep.
we reorient for an entry back through the Earth's atmosphere a little bit later.
So
Plus count.
what this stuff
Second
is.
stage, we see the engine nozzle glowing
I'll
red.
wait till John's done.
Everything continuing to look good on the second stage.
Okay, so this right here is a nitrogen attitude
Be hearing
control
call-outs
system,
coming up to the crew.
or in rocket terms, it's called a cold gas nitrogen thruster. Why is it called a cold gas nitrogen thruster? Because it shoots cold nitrogen gas out of it. Engineers aren't good with names. There's no innuendo. You just say what it is. It's true. So it controls the attitude of the vehicle, right? So what you see, these kind of snowflakes that are coming off, is actually solid nitrogen. The reason why it does that is because when you outgas at high pressure into a vacuum, whatever you're outgassing, the nitrogen in this case, goes from gas to liquid to solid in a second because you're in the vacuum. So if you see little flakes coming off the vehicle, it's solid nitrogen that from the thruster outgassing, from basically the thruster working, which is actually really interesting stuff. You see a similar phenomenon right here. That right there is solid oxygen. Solid oxygen that came out of the vent line from the second stage motor, which is really cool. See, little nitrogen flakes coming off right there. Or it's aliens.
Everyone is still pretty comfy. As John had said earlier, we got to
SpaceX, trajectory nominal.
Okay.
All right, good call out there. That
Flight dynamics officer is reporting trajectory nominal.
trajectory is nominal.
Please don't skip like that
As
again,
John
stream.
mentioned, we got to about 3.5 Gs
Nitrogen-based
there.
aliens.
New Hampshire.
They have an AOS through New Hampshire. SpaceX has a ground tracking station in Manchester. Believe it or not, Manchester, New Hampshire.
On the left-hand side of your screen, we can see the first stage as it is making its way back
We got
down to
telemetry
Earth.
here,
It's
first and
targeting
second stage.
a landing on our drone ship, a short fall of Gravitas,
Cool
which is
for her.
parked a couple hundred miles off the coast of Florida, out in the Atlantic Ocean. Second stage on the right-hand side, everything continues to be nominal there, as the MVAC engine is powering the second stage and Dragon Endeavor
Who's in Denver?
to its targeted drop-off
Kate!
orbit.
Yeah, sure, John. I don't know where it is,
Absolutely
to be honest.
beautiful views of both the first
I
and
know
second
where it is,
stages.
but I don't know where it is.
Trajectory nominal.
Denver would be off course. Yeah, that's right.
SpaceX Endeavour, copy.
MLA says that reporting or confirming that
All right,
trajectory
so coming
is
up in
nominal
about
there.
a minute and a half, the first stage will execute the first of 2 burns required for today's landing attempt. At about T plus 7 minutes and 30 seconds,
Yeah, a little
we'll
bit, Tim.
see the entry burn begin. That's where the first stage will.
What's the foil on the second stage and why is it there? So that's Myla insulative wrap. So it's space blanket. The reason why? The sun up there without the gas from the atmosphere to diffuse it is really freaking hot. And they're pumping really cold propellants, liquid oxygen, through the pumps that are on the motor. It's turbine machinery. They're turbos, big turbos, but like a turbo on a car, but instead of charging air, they move liquid. They got to make sure that the liquid oxygen turbine machinery stays really cool, because if it doesn't, the liquid oxygen will sublimate, it'll turn to gas, and if gas goes into the engine, well, that'll just create a myriad of problems. You don't want that. It's called a liquid fuel engine for a reason. So they cover the second stage turbine machinery with a space blanket to make sure that it stays cool. Because the sun up there will give you a sunburn real quick, believe it or not. Yeah. Without the atmosphere to diffuse the gas, yeah, it gets pretty bad. Now, what you're going to see here is the entry burn. That's going to slow down the first stage here. And also, my favorite part, here it comes. I'm going to say it. Chad, I'm going to do it. There it is. There's the entry burn, 1 engine to 3 engine, if you saw the change in shape. What that's doing there is not only slowing down that first stage, but that's the heat shield. SpaceX takes the saying of fighting fire with fire very literally. What that's doing, if you notice, the first stage is up in space, comes back down. It's re-entering, right? And if it's re-entering, it's going to have entry heating. What SpaceX does is they use the engines on Falcon 9 to push the plasma away. They push the re-entry heating away from the vehicle and envelop it in a nice cool column of gas. Now, rocket, the outgases from an engine is not very cool, but it's cooler than re-entry heating. That's enough to keep the vehicle in one piece through re-entry. That was the heat shield. It's called supersonic retropropulsion, and it's an idea that was developed by NASA for landing payloads on Mars. Yeah, SpaceX likes Mars, from what I recall. Now the boosters, it's going to start getting back into the atmosphere. If you see these vibrations here, that's the deceleration forces from hitting the atmosphere again. The grid fins will shake a little bit.
Stage 1 transonic.
Okay, stage 1 is in the transonic barrier here, so that means it's between 0.8 and 1.2 Mach, or 1.2 and 0.8
that
because
our
it's decelerating.
landing burn and
Hey,
second engine
Air Bennis,
cutoff,
thank you.
Will occur
Okay.
about the same time.
shutdown.
Those titanium grid
All right,
fins
we got
are
a
really
live
going to
view of
start
the
doing
crew
work
inside
here.
Dragon Endeavour there on the right-hand side of your screen.
That
Stage
fire.
1 landing burn.
Okay, got the landing burn through the
Landing
clouds.
burn has begun for the first stage.
SpaceX, nominal orbit insertion.
We have an NOI
All
on
right,
the
great
crew
news
insertion there.
Dragon Endeavour, nominal orbit
Uh-oh.
insertion.
Okay.
SpaceX Endeavour, we copy, and it's great to be here.
Okay, landing legs have deployed.
Stage 1 landing leg deploy. SpaceX Dragon launch escape system disarmed.
Stuck
As
the
you can
landing,
see,
baby.
This Falcon 9 has landed for the 5th time.
A little windy out
All
there.
the
She's
while,
a little
great
off center.
commentary
Landing
there.
confirmed.
While we can confirm the landing, confirmed landing there of the first stage booster. Also, almost simultaneously, great news
Nice.
For the second stage. We heard
So-
that it was nominal orbit insert.
A lot of stuff just happened there. So, you had a nominal orbital insertion call. NOI means that they're in the orbit that they expected to be in by the time the second stage engine cut off. So the second stage shut off, the flight trajectory officer called a nominal insertion, which means that they're where they needed to be. Or where they need to be, I should say. The mission isn't over yet, right? Second thing you heard there, the launch escape system, that integrated launch escape system that they armed before fueling, if you've been with me this entire time. Chris and Toity, thank you for the subs, man. I appreciate it, guys. They disarmed it because it's not needed anymore, so they have inerted the Super Draco motors on the Dragon capsule. And then the third one, which is probably the easiest one to see, is that they landed the first stage. So I believe that booster is 1062. Will live to fly another day, and will be recovered, and they'll tow it back, and they'll use it again.
Now that, as we said, Dragon has nominal orbital insertion, the second stage and Dragon will separate.
Discovery, go at
Thank you for the subs, guys. Renkar with the 9-monther.
Use there
Thanks,
of
dudes.
our MVAC engine. Now,
Why are they
shut
holding
off,
their arms up?
no longer glowing.
I was going to explain it to you.
That lovely shade of orange.
Because they want to wave at you. Yeah. Lord Go, they do good. Now, okay, what you're looking at here.
Right now, the second stage is about 200 kilometers above Earth.
Yep, they're going to get a deploy here. You're looking up the business end of Dragon right here.
Right now for stage separation.
Okay.
For Dragon separation.
They will deorbit the second stage. It won't stay up there. Thank you for the anonymous tips and the anonymous gift subs, guys. Thank you. I appreciate
it.
it.
That have just recently joined us, we had an
Okay.
on-time liftoff.
I'll tell you about the UI for the map view in a second here.
Now, in space and coming up to separation from second stage, at which point they will then begin to make their journey, continue their journey to the International Space Station.
17,500 belt fit is what they're looking for, miles per hour, or about 7,600 meters a second. There we go.
Inside the Dragon trunk, which, as you can see, has just separated from the second stage.
Dragon separation confirmed.
Seen a little bit of that solid nitrogen, those solid nitrogen flakes around.
The Falcon 9 team, welcome to space. Thanks for flying Falcon 9. Guys, enjoy your trip to that wonderful space station in the sky. Do some great research for us. We'll look to see you back here underground. Now stand by for some words from LD.
It's really cool.
And MLA and the rest of the crew Endeavor. Glad we got to have some fun this morning. We'll probably be calling an early weekend over here at the Cape. Pass you over to Anna and the team. You'll be in good hands.
Look at
Enjoy the rest of
look
your
at the
flight.
RCS on Dragon working. Oh, that's so cool. Did you see it? They modulate the thrusters for temperature, so they go.
Eventually, guess we had a little bit more than
Pete.
Thank you and your launch team, Girth, you and the Falcon 9 team. That was a hell of a ride, and we're looking forward to the next 10 days.
MLA
Alright, so
thanking the
nice
launch
words
director for
there
the
from a
flight
couple
there.
of key folks.
Oh, look at that. That's a live shot inside of a spacecraft being streamed to your computer.
Of the mission.
Yeah. I queued up right
Can you believe that?
There we can
Expected loss of signal, Bermuda and New Hampshire.
there we can see
They should have
Dragon
a,
Endeavor on its way to the International Space Station.
there should be a momentary loss of communications here before they'll report a acquisition of signal through Goonhilly in Cornwall. That's where the next ground station is. You can see that's the checklist right there. We could see some you can see some telemetry here from the orbit. There are T+. Well, that's actually, that camera's delayed a little bit. It's a little bit behind. But when they show that again, I'll show you guys the orbital information for the nerds if they want to see that.
Live view inside the
Okay,
cabin. They just
take
got
your helmets
the
off.
okay to lift their visors.
Thanks for all the subs, guys. I appreciate it. I don't know, Swishio, maybe. Oh, nice, T-Man. You saw it.
So we can see that everyone is in space.
Yeah.
We can see that zero G
It's human space
indicator
program fun.
floating around. Great view there. Of
Look
Dragon
at that.
Endeavor.
It
Now in
might be
space with
Swishio,
the
yeah.
Axiom-1 crew on their way to the International Space Station.
Bunny!
Yeah, I mean, this is a day of
Chat, put the bunny back in the box. Okay.
for spaceflight, and it's just wonderful to see such a picture perfect launch.
It really was.
We saw the landing, and we saw orbital or zero G insertion at the same time. I mean, that was perfect.
Yeah.
It was wonderful to see.
So they should have an it looks like they still have an acquisition of signal through Newfoundland, and they'll lose that for a second, and they'll get reacquisition of signal through Goonhilly. You'll hear it on the comm loops here, but let's see what Kathy Leaders has to say about this. She runs NASA's human spaceflight operations.
Operations Mission Director. It's so great to have you here, Kathy. What did you think of the launch?
Oh my gosh, it's always like, right in the bottom of my throat. I'm holding, I can't breathe.
Yes.
But it's What a beautiful, beautiful sight.
Yeah.
So good to see
Bunny
it.
also
I
paid.
want to tell everybody working Artemis 1 wet dress, we're off the range. We're off the range for Axiom-1, and we can
don't
get
say
moving.
that to
but,
me.
You always want
Don't
to
say that to me
hear
again.
the engine cut
Miss
off.
it
You
so
always
much,
want to
dude.
hear that second stage engine's lighting. You always want to hear, each of these stages, and we need to just keep carefully working through the different steps to get that crew there to the International Space Station safely.
Yeah. What does Axiom-1 represent? Axiom-1 and also future private astronaut missions to the International Space Station.
Hey, NASA's original goal was to enable commercial industry. That was actually in our original Space Act agreement. And so here we are, 60 years later, enabling that through our missions. And so I just feel like this is a culmination of 60 years of work for us. And here we are once again getting to see, and for the first time getting to have commercial, private astronauts going to the International Space Station. And they'll get to see what our government, what they're calling professional astronauts doing their real work, but then also getting to do their work too. And it's another place where learning to peacefully work in space, I think, is moving us forward.
Yeah, so important. And we just watched Axiom-1 lift off from that launch pad right there behind us. In a couple of weeks, we're going to see Crew 4 launch from that same launch pad. And then just right next to it, Pad 39B, we have NASA's brand new Space Launch System. Can you recall a busier time we've had here at the Space Coast? And how is Kennedy Space Center managing its new role as this multi-user spaceport?
So I think somebody else, Bob Cabana had this dream of a multi-user spaceport here. So I think he should be very, very proud of his KSE team, and Janet Petro and her team are obviously leading the way right now. Because this is not easy to do. It's not easy to go make sure all of these people have all the capabilities and are obviously working with our Air Force sister agency there too, and making sure that all
next
of
launch
these
from that
launches
pad
get
in the background there is another crew launch.
It's an amazing job.
Yeah, a lot of juggling.
They did Kettle One, yeah.
So, I just talked about SLS. We are looking forward to the moon with that launch later this year. Why is it still so important to maintain a presence in low Earth orbit when we're looking towards the moon now?
Because we still don't have everything figured out how to do things yet for the moon and Mars. And really the cheapest place for us to see a differential gravity environment and for the long term is still LEO.
Yeah.
And so we've got to continue to do these long duration flights, keep doing our medical protocols, keep doing our physical protocols, keep testing out our equipment through those long duration missions. It's the only place where we can do that right now.
Yeah.
And so we still need to be able to have this kind of a test bed for us to be checking out and proving our protocols, our research, our technology
10 days
before you go put somebody in a rocket that's going to go to Mars, right? So just like always, we prepare, we get ourselves ready, and a low Earth orbit destination is a perfect place to do that.
And again, how does us fostering
Starship is the reusable
commercialization
second stage,
efforts in
Bob.
space, how does that free us up
That's the plan.
to pursue
Nothing with
these
Falcon
other
9
dreams
if that's
that we
what you're
have as an
asking.
agency?
So, the administrator today in the pre-mission conference, he said,
Tomorrow, Zelda.
We right now are doing, this is our first step. We're working with a commercial company to have them come to our International Space Station. And we're learning to work together and figuring out how to work together. And this is going to be an important step for us because moving forward, we would actually like to now be able to buy a ride and time on orbit with
Kathy
a commercial
Leaders
company to be able to have them do that.
She runs human spaceflight
And so
operations
this is the first step
for
of their
NASA.
learning from us and us learning from
She's
them.
cool.
And then in the future, we're going to have Space Station for another 8 years, but we would like by the early 2030s for us to be flipping the roles and have our professional astronauts going up and checking and doing and focusing on the research and technology we need for exploration, but allowing commercial providers to be doing the hard work of maintaining the laboratory.
Kathy, what an exciting future. I'm looking forward to seeing it, and thank you again for being here.
Thank you.
All right, back to you, Dan.
Danny.
All right, hey, thanks, Megan. It is great to see the AX-1 mission on orbit. The team
look,
here,
see that little icon right there
station
on the screen
are
behind
ready,
him?
ready to get
There's
them
Dragon.
on board. So their journey just started. They've
northeast
got
of
about 20 and a
Newfoundland.
half hours until they're docked to the space station. Again, they're headed for the Zenith port on Node 2. That's the space-facing one on the very top. With that docking scheduled right now for 11:45 GMT on Saturday. That is just about 6:45 a.m. here in Houston, 4:45 a.m. for
telemetry
the
back
teams
there.
out on the West Coast. Once they get there, we'll be able to get into all of the hatch open operations, welcome them on board. We expect the hatches to open up about 2 hours after that docking, maybe a little bit less, and then that welcome ceremony coming not too long after. So that'll do it for us for today. Elise here from Houston.
ISS
We're going to be
operations,
joined
Blue Shorts.
again
I forget what
tomorrow
it's
by
for.
the SpaceX and the Axiom team as we walk you through the final stages of the rendezvous, and that coverage is going to be starting at 4:30 a.m. Central, 2:30 a.m. So an early morning, my friends over there on the West Coast. So with that, again, congratulations to the SpaceX and Axiom teams for getting this crew on orbit. We'll be ready for them tomorrow to get them on board the space station. I'll send it back now to the team at Hawthorne and over to Kate.
Thanks so much, Dan. Actually, just heard in our ears just now, successful nose cone opening.
Nose cone houses the docking port. You got to open up the nose cone to make sure that it can dock correctly.
All right, so that was basically the last physical step for this morning. So that we're gonna start wrapping it up. Now, over the next 20 hours, Dragon
Station
will
power,
execute a series of
articulation,
burns
and
to
thermal
gradually
control.
raise and
Thanks,
line
War Hero.
up the AX-1 crew for docking with the International Space Station in what we refer to as the activation and rendezvous phase of the mission. Now, in just a few minutes, the crew will
Gotta
dock
prove that
or
it can be
take
done,
off
Swishio.
their spacesuits to get a little
Takes
more
time to
comfy
do
for their
that.
flight and will enjoy their first meal aboard the spacecraft. At 2 p.m. Pacific, they will get ready for a rest period that will last for about 10 hours, 8 hours for actual sleeping, and a couple of hours for pre/post-sleep activities. Before they arrive at the space station, we will have 2 potential opportunities to chat briefly with the crew on orbit. One later this morning around 11:10 a.m. Pacific, and one early tomorrow around 12:10 a.m. Pacific. While we're hopeful one of these will work out, neither opportunity is guaranteed as they're dependent on crew schedule and ground station coverage.
Yep.
Now, if we're able to support, we'll make an announcement on our social media channels no later.
Guys, I just want to point out that there's a Falcon Heavy nose cone sitting in the background there, just for the keen-eyed, in case you were wondering. Yeah, there's a Falcon Heavy nose cone back there.
Launches.
Right, and as Kate mentioned, even if we aren't able to talk live with the crew, we will continue to provide updates on the mission across our social media channels.
Just thought I'd
And
let you
starting
know.
At 5:30 Eastern, 2:30 a.m. Pacific on Saturday, April 9th, we will
That's
pick
cool,
back
Kuro.
up with our live joint coverage of the AX-1 crew's approach and docking to station with NASA. So please.
Actually, the other thing to look at is the mandrel over there for the fairings. See the fairing? They got the fairing wound on the mandrel. That's a Falcon 9 fairing being made back there. Note that the fairing manufacturing is inside of a clean room to make sure that no debris gets in there. Yeah, see? Pretty cool.
Again, we hope to see you soon.
All right. Because I'm awesome, Zelda. All right. Well, everything looked good there. First stage landed. Second stage had a nominal orbital insertion. Capsule separated on time. Everything looks real good. Yeah. I hope you enjoyed the Axiom-1 launch coverage. I'll try to pick it up with the docking and everything. It should be happening tomorrow. It's going to be early. But, no orbit coverage from what I can tell here. It's not a NASA mission. So, yeah, it's just on the title screen. Man, guys, I want to tell you, SpaceX really makes this look easy. They really make it look easy, man. This is not easy to do. I mean, these missions go off pretty much, thus far, I don't want to jinx anything. These missions are going off without a hitch, man. It's no problem. You know, the worst thing they worried about was the hatch not seating correctly, and they fixed that instantly. I just want to point out that it's not easy to do. It really isn't. This is a culmination of the efforts of thousands of people. And to have it all come together and have everything go right, and the only thing to go wrong was, the hatch doesn't seal all the way the first time and seals perfectly the second time, is pretty ridiculous. That's a pretty good amount of effort being put in there. So appreciate it. It's pretty freaking cool. I would say that you don't get to see this every day, but I mean, here we are. The next launch out of 39A in just 20 days is another crew launch. It's Crew 4 to the ISS. The proof is in the pudding. No. When will space tourists be able to go to space without everyone knowing? I don't know, Swishio. Yes. I don't have a crystal ball, man. Having the same issue twice is a little concerning, no? Depends on what it is. If the toilet doesn't work, then that's a little bit more severe than not having a hatch seal the first time. Sometimes that happens. Sometimes you're at the limit of material engineering, dog, so that's the best way for it to work, and sometimes that way has a little bit of issues, 10 days demo. Do you think 4 capsules will be enough for demand? Yes. And for what it's worth, dog meat, SpaceX did have the toilet break. Crappers clog. Merry Christmas. No, seriously, the toilet did break. The seals weren't working correctly, and the toilet leaked. Pea icicles. Yeah, that's all you need to know. But they fixed it. I've made those on Earth. What mission was that on? That was on Inspiration 4, actually, if I'm remembering right. Yeah, at least they're frozen. You don't have to worry about biohazard. Actually, you know what? It wasn't pea icicles demo. To be honest with you guys, the toilet leaked under the floorboards. Probably smelled terrific. Yeah, the seals didn't work in the toilet, so yeah, it kind of leaked. But hey, they fixed it. You have teething problems with spacecraft. It happens. Even with the head, it happens. I mean, at least it has a toilet. I'm about to ruin the Apollo program for you. The Apollo Command Service Module didn't have a toilet. No toilet. They had Ziploc bags, though. Yeah. You didn't want to hear that, did you? What? Ziploc bags were lighter. It's true. That's all you really need. They had pee jugs, man. No. Yeah, yeah, exactly, Jim. They left it on the moon. There are bags of poop in pee jugs on the moon. No joke. They threw it out. They literally threw it out the window, Loggy. That's right. Yeah, seriously. Depress the capsule, throw it out the window. That is exactly what happened. Yeah, pretty much, Bear Lizards. I mean, the Mercury capsule is basically launching in an EVA suit. Yes, they did, Crab Shark. Yep. Should we go get it back? We should go get it back. Wet mass, indeed. And that was an improvement. Yeah, that's right, Duckman. That's right. Oof, demo. Oof. I agree, John. We should do that. I think, personally, that NASA's first mission back to the moon should land at Taurus Littrow. They should land next to the Apollo 17 landing site. Pick up right where we left off. Yeah, right, Organic? I've shook a guy's hand that could say that, to be honest. And I played Kerbal with him, too. Yeah, when we said like that, I probably should have washed my hand. All right, guys. Well, that wet mass certainly ruined the delta V equation for you. I'm glad I could help. All right. I don't know. Demo. Yep. I think the South Pole would be the best option, no? Get right to brass tacks on the whole colonization thing. Yeah, maybe. I'm sure NASA's working on a bunch of different plans. Anyway, guys, if you don't mind, I'm going to take a little bit of a break. If you don't mind, I'm going to restart up the stream probably, well, it's noontime now. I'm going to go have some lunch, and I'm going to restart the stream at 1, and then we'll just keep going with early hours. I do mind. Oh, that's nice. Tom Vanini made some bold claims in the new KSP vid. He says they're killing the Kraken. Okay. You want a coffee, IV? I'm gonna go get some coffee and donuts, Geese, and I'm not gonna lie. So, I'll be back in about an hour, guys. I hope you enjoyed the Axiom-1 coverage. I'll keep you guys in the loop. For everybody else, if it's your first time coming to the stream, well, I hope you appreciated it. I cover pretty much every rocket launch that I can here, every SpaceX launch. I've missed one SpaceX launch over the past 10 years, and that's when I slept in by accident. What? There was a lot. The only reason I slept in is because there was a launch the night before it, damn it. Or at least I think there was. Doesn't matter. Anyway, so yeah, I try to cover everything. So I hope if you enjoy my launch coverage, or stick around. If not, that's fine. I'll see you guys in about an hour. Thank you very much for watching, and well, yeah, I'll see you in a little bit. Can we watch a KSP video before the break? No. We'll watch it when I get back, dude. Especially because if I watch it right now, everyone's going to want to talk about it, and I'm going to end up not taking a break. I know me. I know me. Know thyself. That's right? Right? Am I right? Okay. So, I'll see you guys in about an hour. We'll be back. And thank you for watching.